Hey guys, and welcome back to another video. This is the Introduction to Data Analytics series, and in this series we'll be talking about the introduction to data analytics, where we are going to talk about the KDD process, which is also known as the knowledge discovery in database. Today's video is going to be covering step 3 of this KDD process, which is known as data cleaning. Now, before I get started, there's something that I noticed in my earlier videos. In my previous videos, I spoke about APIs, where I said APIs are application process interface. So just to correct that, it's not process, it's actually program interface. So APIs are application program interface and not application process interface. So yeah, this was just one thing I thought I'll let you guys know. So let's get started with today's video. Today we'll be talking about data cleaning, and we'll be discussing the different techniques and steps to actually look at noise in your data and how to actually clean that specific data. So as a data analyst, I'm sure by now you have probably guessed that you will be working with a lot of data. Now, bear in mind, when you receive this data will not be cleaned. Because every company has different ways of actually maintaining their specific data. So when you're receiving data from, let's say, a web source, or from the company, or let's say third party, it's not going to be clean. Expect a lot of noise within that data. Expect yourself to spend a lot of time cleaning that data. So that's what we're going to talk about today. We're going to talk about the different types of noise that you can potentially find in your data set. The first type of noise that you may encounter when you receive this data set is a lot of NA values. Now, your NA values are essentially your null values. Okay, so what are null values? Null values are basically, let's say this is your data set, and this is your name, age, height. Let's just consider this as the 3 variables. Now let's say you have data, you have 4 people who did the survey, you've got 4 age, and let's say you've got 1 missing height. So this 1 missing height is your null value, because you do not have any data for that specific row. Now, what you can do when you're cleaning this type of data set, the best thing to do is disregard this entire row and take it out from the data set. Now, if we try to understand how many rows we have, so let's say we have 4 rows before the data was clean, and after we remove the null values, now we have 3 rows, but the columns, they remain the same. Now, we remove null values because when we do modeling, these null values hold no predicting powers, and they do not contribute to our data modeling. So that's the reason why we completely disregard the entire row which has null values. So this is one type of data that you can expect in your data set. The second type of data that you may encounter could be, let's say, timestamps. Now, what are timestamps? As a company, let's say if you're working on some sort of time series analysis, or let's say you're looking at a company's sales data. All right, so let's say you're looking at a company's sales data. You've got your date, you've got your number of sales, and you've got revenue. Okay, now there is no problem with number of sales or number of revenue, but oftentimes what happens is that when you get these data from the companies, your date and time could be converted into a different format. Let's say you may receive rows like 1 4 3 7 5 1 8. Now these numbers represent some sort of date and time. So what you need to do is, when you receive dates in such a manner, you would need to convert them into date and time. Now, depends on what type of problem you're solving. Let's say if you're working on time series analysis, then you can convert these to get a better understanding of your data. But if you're just running a simple regression to predict the revenue, then you don't need to really convert your date and time, because then this wouldn't have no predicting power when you're working with revenue. So this was to do with timestamps. So in case you ever come across a data set which is just numbers, or dates which is just number, then understand that you have to convert that into date and time if you're doing some sort of time series analysis. Now, the third type of noise that we can see in a data set, or can be expected in a data set, are known as outliers. Now, outliers are basically numbers which fall outside a specific range. Now, let's say height. The height of an average adult is, let's say, 5'11". Let's say between 5'9" and 5'11". If in your data set you have height of, let's say, 7 feet, then that becomes an outlier in the data set. Now, there are different ways to handle these outliers. You can eliminate these outliers, or you can keep them depending on the type of problem statement you're working with. But this is just an example of heights. In case you want to visualize outliers, I think the best way to do that is by using a box plot. A box plot would show you, let's say, this is where most of your population falls, and then these could be your outliers in the data set. So outlier detection is also known as anomaly detection, where you're looking for outliers in the data set. Now, the fourth type of data cleaning that you want to do is known as data sampling. Now, I've already given an example of data sampling in my first video where I spoke about the KDD process. I gave an example of the cancer data set. So now let's give a different example. Let me give you an example of, let's say, insurance. Let's say you have a data set of insurance, and you want to predict if a person has, so let's say caravan is the type of insurance this company sells. So you have to predict if the person has caravan insurance, yes or no. So when you're presented with this type of data set, you would have majority of your data which do not own the caravan insurance, and very less number of people who may have a caravan insurance. Let's say this data is split in 95% of the people in your data set not having a caravan insurance and 5% of people actually owning a caravan insurance. Now, what is the problem with this specific data split? The major problem is that this data is highly imbalanced. Now, why can we not work with highly imbalanced data set? Now, let's say if we were to build a model based on this type of data split, the target variable split between 95 to 5%, what would happen is that if we do go ahead and model this data, 95% of the time the model will predict the customer does not need caravan insurance. And this is not a true representation of the model because this model is biased. So when you're modeling, you need to eliminate any source of bias in your data set. So that is the reason why we are not going to go forward with this 95 to 5% split. In these cases, what we do is that if you do evaluate the specific model, you're going to get an accuracy of 95%, and you would think that, oh my god, my model is working so well, it's giving me such a high accuracy, but on the flip side, it's biased. The model is completely biased, and this is not what you want. And that is why confusion matrix exist, where you find out the true positives in your data set, where you find out the true negatives in your data set. And I will talk more about confusion matrix and accuracy when I'm talking about the evaluation part of data modeling. But as of now, it's very important for you to understand that if you have a highly imbalanced data set, what do? You can perform two things. You can either do undersampling or you can do oversampling. Now in undersampling, what happens is that you are basically decreasing your numbers of no's. So let's say now if you have 95% of the people in your data set which do not have a caravan insurance, you're technically you're just removing those extra rows in order to balance the data. Let's say you remove the number of no's from a data set and you balance the data to an 80-20% split, which is a fair split. So usually when you're trying to balance your data, you can do a 60-40 split or a 70-30 split or a 80-20 split. Now people usually do 70-30 or an 80-20 split when we're working with highly imbalanced data set, but never do a 50-50 split. Now when we're working with oversampling, what you're doing is that you're creating random rows to increase the number of your yes. So what you're doing is technically filling random values to increase 5% to 20%, and you're populating the data, but at the same time you're reducing your noise as well. So with oversampling, you are increasing your yes to 20%, and at the same time decreasing your no's. And with undersampling, what you're doing is that you are decreasing your numbers of rows, so that you can increase your number of yes. So let me just put it this way. Perfect. So that's done. Okay, so that was undersampling, that was oversampling. Now, when you're working with undersampling or oversampling, you need to understand that there are some trade-offs. Let's say when you're doing undersampling, you are removing rows, which could mean that you are losing out on important data from your data set, because you're randomly just removing 15% of your data. That means that you may lose some rows which may contain crucial information for modeling. So that's one of the trade-offs when you're working with undersampling. When you're working with oversampling, if you want to oversample your data, what you're basically doing is bringing a lot of randomness. So with oversampling, as I said, that you're increasing the number of yes and decreasing the number of no's at the same time. So with oversampling, what happens is that a lot of time you're adding more data into your data set. Another trade-off could be that when you're adding data, or when you're adding more rows to oversample your data, you may have data which has no predicting power for modeling. So that is another trade-off when you want to oversample a data. So just to summarize, so let's just summarize the different types of data cleaning that we have learned today. So the first one was null values. We remove any sort of null values in the data set. The other one was timestamps. If you're given data which is in a form of number, especially dates, and you want to do time series analysis, you can convert that, or you have to convert that into date and time. The third type of data cleaning we dealt with was outlier detection, or this is also known as your anomaly detection. And then your fourth one was to do with sampling. When you have a data set, and especially in that data set, the target variable is a variable that you want to predict. If that variable is highly imbalanced, then you have to balance those data using either oversampling techniques or undersampling techniques. These are the most common ones that you would see when you're working with any sort of data set. So look out for them. If you do see them in your data set, make sure you take the necessary steps to approach the data, and you clean it in a structured manner. Thank you so much if you stay till the end. Thank you for all your support. And as I said in my earlier videos, I'll be making a Dropbox link where I can share this notes with you. Thank you so much once again for staying this long. And if you guys have any questions, just leave them down in the comment section below. Or if you guys just want to connect with me, I have dropped my LinkedIn in the comment section below. Just hit me up on LinkedIn and we can connect. Also, do share this video. Do give it a like if you like the video. If you did not like the video, give it a dislike. But do interact with the video, either with a like or with a dislike. It would really help me a lot. So thank you once again for staying, and I will see you guys on Monday now, where I will be talking about the fourth step of the KDD process, which is your data pre-processing and how to pre-process data. And then next Friday we'll be talking about data modeling. So thank you once again, and I hope you guys have a great weekend, and I will see you guys on Monday. Thank you so much. Bye bye.